Hello all. Today I am going to discuss about the synthesis and chemical reactions of indoles. Now we are going to discuss about the main topics in indoles like physical properties of indoles, methods of synthesis, chemical reactions and its applications. In this video we are going to discuss only up to methods of synthesis, and we are going to discuss only about one method today. Now the physical properties of indoles. Indole is an aromatic heterocyclic compound with a bicyclic ring structure. According to Hans-Wittmann nomenclature, this indole has a name called benzo-B-pyrrole, and indole is the common name for this structure. Molecular formula is C8H7N, and it was first prepared by Adolf Bayer in 1866 by the zinc dust distillation of oxindole, and it has a resonance energy of 47 to 49 kilocalorie per mole, and it is soluble in most organic solvents, and it is soluble in most organic solvents, and it has a colorless crystalline solid. Now the resonance structures of indoles. In this resonance structure there are 6 structures. In the first structure, the lone pair of nitrogen shifts to this position and there forms a double bond in the second structure, and this nitrogen acquires a positive charge. When this double bond shifts, there forms a negative charge here, and when this negative charge shifts to this position, there forms another double bond in the third structure. And when this double bond in the benzene ring shifts, there forms another negative charge. And when this negative charge shifts, there forms another double bond. And when this double bond in the fourth structure shifts, here forms a negative charge in fifth structure. And when this negative charge shifts, there forms another double bond in that pyrrole ring. And when this negative charge shifts to the original position, there forms indole. That is the sixth structure. When this double bond shifts, this nitrogen will not have the positive charge. According to the resonance structures, electrophilic substitution occurs at the C3 position than the C2 position because it is more stable than the C2 position. Now we are going to discuss about the methods of synthesis. There are 4 methods of synthesis for preparation of indole: Resart synthesis, Madelung synthesis, Bischler synthesis, and Fischer-Indole synthesis. Here we are going to discuss only about the Fischer-Indole synthesis. This is the reaction which involves a primary aryl amine reacts with an aldehyde or ketone in the presence of an acid catalyst. This acid catalyst can either be a Lewis acid or Bronsted acid. In this reaction, this phenylhydrazine attacks a ketone and here undergoes removal of water to form a phenylhydrazone, and when this phenylhydrazone undergoes acid catalyzed rearrangement in the presence of zinc chloride, it forms 2,3 disubstituted indole. Now we are going to look upon to the mechanism of Fischer-Indole synthesis. In this Fischer-Indole synthesis mechanism, there are 2 steps. These 2 steps are part of an equilibrium, hydrazone-ene hydrazine equilibrium. In this first step, the lone pair of nitrogen in the phenylhydrazine attacks the ketone's carbonyl group's carbon, and when the C double bond breaks, and it forms another structure with a negative charge on oxygen, and it undergoes some reaction to form another structure with an OH group, and when this structure undergoes removal of water, it forms a phenylhydrazone, and in this phenylhydrazone this CH bond shifts and the C double bond and breaks. There forms phenylhydrazone with a double bond in this position. And now when the structure undergoes protonation, there forms ene hydrazine, and this ene hydrazine undergoes 3,3 sigma tropic rearrangement to form a double imine. And in this double imine, the CH bond shifts and the C double bond NH breaks to form the structure. And in this structure, this lone pair of nitrogen shifts to this position, and which is this C double bond, CNH2. The lone pair of nitrogen attacks this bond, and the C double bond NH2 breaks. And after that, in the structure, removal of NH2 takes place to form a 2,3-di substituted indole. By this, we are concluding today's class. Hope you all understood the topic. Thank you.